So today we're going to be looking at activity 25. So we are going to be looking at all of activity 25 today, which is going to be dealing with arcs and angles that are created by a radius or by chords or by a secant or tangent. And so we're going to hit some of the high points on these concepts. We're not going to go into quite as much detail as what your book does for the sake of time this year. So we're going to start off with a central angle. It's an angle that has the vertex at the center of a circle. That's why it's called a central angle. The vertex is the point, the little edge here. It's going to be at the center of your circle. And so then these lines are each the radius. They're the radii of the circle, and that creates a central angle. Central angles are subtended by an arc. So the arc that subtends the angle is here. And so basically what that means, it creates an arc. And it says the angle of the arc is the same as the central angle measure. So whatever this angle is, whatever that measure of that arc is, this angle is going to be the same thing. So let's look here. We have a 60-degree arc. If you look, this angle is subtended by this arc. And so what that means, this central angle is going to be 60 degrees. Looking at the next one, we have this angle here that is 105 degrees. This arc has a measure of also 105 because it's the same as the central angle. On this next one, here is our angle, and the arc that subtends it is the 53x plus 1. So we can set up an equation here. 53x plus 1 equals 160. So if you subtract 1, 53x equals 159. And then divide by 53, and you get x equals 3. So that's how you can use your central angles. Now let's look. A circle in total is 360 degrees. So if you know all of your angles, they all have to add up to be 360. A diameter is going to divide a circle into two congruent semicircles. So if you have a circle, remember, a diameter has to go through the center of the circle. It cuts the circle in half. And so the angle over here is 180 degrees. And then the angle over here is 180 degrees. And then vertical angles still hold true here. They are going to be your congruent angles that are formed by intersecting lines. So let's look at an example. We know that we have a diameter here. And so if you look, all three of these angles create that semicircle. So we are going to say 55 plus 4x plus 6 plus 7x minus 2 equal to 180. Because this is a semicircle, so all of this has to add up to equal 180. So then if you solve that equation, combine like terms, 55 plus 6 minus 2 is 59. And then 4x and 7x is 11x. Equals 180. So then subtract 59, 11x equals 121, and divide by 11, you get x equals 11. So that's possibly how you might use your diameter. Or you could look at it. This is 55. This angle is vertical. These two angles are congruent. So this is 55. And you could have used this diameter. Required a little bit more work, but you still end up with the same equation, 55, 7x minus 2, and 4x plus 6. So same idea, just however you want to set it up. Looking at this next one, again, we have a diameter. And we know that the diameter creates a semicircle that has 180 degrees. So this arc is 180 degrees. So we can say 19x plus 4 plus 10x plus 2 equals 180. So combine your like terms and you have 29x plus 6 equals 180. from there, subtract 6, so 29 equals 174, and then divide by 29 to get 6. Okay, so now let's look at an inscribed angle. An inscribed angle is the angle that is formed in the interior of a circle when you have two chords or secants intersect on your circle. So it could be a chord if it goes from one side to the other and stops, or if it continues, then it's the secant. So it's the same idea whether it's a chord or a secant. So an inscribed angle has to have the vertex on the circle. Up here, the central angle has to be at the center of the circle. So that's the difference between the inscribed angle or the central angle. Where is the vertex? So it says an inscribed angle is half the measure of the intercepted arc. And that's what this formula right here shows you. The angle ABC is half of this arc AC. So your angle is the arc divided by 2. I want to point out this little term has a little arch over it. So this is called arc AC. So we're going from point A to point C. So it's not just AC, because that's typically a line segment. So to note that you're talking about an arc, you make it a little arc symbol. Little arch over it, kind of like a little rainbow. So now let's look, I've got a couple of other figures here. The inscribed angle here, subtended by the same arc, are going to be equal. So if you look, this angle, and this angle all have the same arc. They all are subtended by that same arc. So that means that all three of these are half of the same number. So they're all going to be the same angle. Now, on this next one, we have a semicircle. So this is our semicircle. We know a semicircle is half of a circle, or 180 degrees. Then, this inscribed angle is half of 180 degrees. So half of 180 degrees is 90 degrees. So that means that this is a right angle. So if you look at this example right here, this is a diameter. So this arc up here is 180 degrees. And that means that this is a right angle, which we didn't specifically need for that figure, but that's what is created. So if you have a diameter, you're always going to have a right angle, a right triangle in that figure. And then this last figure is just showing you that whatever the central angle is, this arc is the same thing, and then half of 2x divided by 2 is just x for your inscribed angle. Okay, so if you know your central angle, just take it and divide it by 2 to get your inscribed angle. So let's look at some examples. We're going to use this formula here. The angle equals the arc divided by 2. So on our figure, the angle is 47 degrees. And it equals the arc. Well, I don't know the arc. So I'm going to say the measure of arc BC divided by 2. And then from there, we're going to multiply by 2 on both sides. And so that gives me 94 degrees for the measure of arc BC. Looking at another example. The angle is what you start with. So the angle on this one is angle Q. And it equals the arc, which here is the arc. So that's 156 degrees divided by 2. The angle is the arc divided by 2. It's half of the arc. So that means that the angle is going to be, and I should say the measure of the angle, is going to be equal to 78 degrees. Then the last one. The angle they give us is 45 degrees. And that equals the arc, which is 17x plus 5 divided by 2. So then multiply it by 2 on both sides of the equation, and you get 90 equals 17x plus 5. So subtract 5 and you have 85 equals 17x. And then if you divide by 17, you get that x is equal to 5. So that's how you can look at inscribed angles. Now looking on the next page, we have intersecting lines inside of a circle. So it could be chords or it could be secants. It just has to make sure that it's inside the circle. So if it's a secant line, it's going to be going continuing outside of the circle or like that. It's the same idea. Typically it's just chords, but it has to intersect inside the circle. And when that happens, the measure of the angle formed is half the sum of the measure of the intercepted arcs. So this is, it says angle BED, so that's this angle here. We know these two angles are the same because they're vertical. And that angle is equal to half of the measure of the two arcs here and here. So add these two arcs together and divide by 2 to get these angles. Or if you're looking for these two angles, you would add the intercepted arcs, which is this arc and this arc, and then divide by 2. So on this one, the formula is the angle equals an arc plus an arc divided by 2. So same or very similar format. Angle equals arcs plural divided by 2. So let's look at an example. On this first one, they tell us the angle is 105. So 105 equals, and then our arcs. Well, one of them is 77, and the other one we don't know. So 77 plus the measure of arc KL all over 2. So then you're going to multiply by 2, and I get 210 equals 77 plus the measure of arc KL. So then if I subtract 77, I end up with 133 for the measure of arc KL. So that's how you would set that up. So let's look at another one. Angle. Well, on this one, we don't know the angle. So I'm going to say the measure of angle QPR, and then arc plus arc. Our two arcs are the 125 and the 75. So 75 plus 125 divided by 2. So you have 200 divided by 2, which is 100. So the measure of angle QPR is 100 degrees. So that's if they're intersecting inside of a circle. Now we're going to look at if they're intersecting outside of a circle. So if they are intersecting outside of a circle, there are 3 possible figures that we're going to have. The first figure is if we have 2 secant lines and they intersect outside of a circle. Then it says that the measure of the angle formed is half of the difference of the intercepted arcs. So the angle is this angle here. If you take your 2 arcs and subtract them and then divide by 2, you end up with your angle. So this formula would be the angle equals, I'm actually going to write it over here. The angle equals an arc minus an arc over 2. So it's important that you think about the minus sign. If I am not careful, I'm going to end up with a negative angle, and angles aren't negative. And so when you're doing arc minus arc, you need to make sure that you're looking at the larger arc and then doing the smaller arc, because you don't ever have a negative angle. So let's look at this first example. The angle, they tell us, is 45 degrees here. So I can say 45 equals, and then I've got 2 arcs. One of them is the 165. The other is the arc CE. So I can say 45 degrees equals 165 minus the measure of arc CE, all divided by 2. So then multiply both sides by 2, and I have 90 equals 165 minus the measure of arc CE. So there are a couple of options here. You could add the CE and then subtract the 90, or you can subtract the 165 and then divide by a negative. So if I subtract the 165, I'm going to end up with negative 75 degrees, and that is negative the measure of arc CE. So then if you divide by negative 1, that'll give you that the measure of arc CE equals a 75-degree angle. So now let's look at the second example. So looking at this next example, you want to start by identifying your angle. So our angle is angle F here, and we don't know angle F. So I'm just going to say the measure of angle F. And that's going to equal the two arcs, and it's the difference of them because we're outside of the circle. So our two arcs are 148 and 78. Obviously 148 is bigger than 78, so we're going to say 148 minus 78, and then divide by 2. So 148 minus 78 is 70, and divide by 2 gives you 35 degrees for your measure of angle F. So that's if you have two secant lines intersecting outside of the circle. Now let's look at one secant and one tangent line intersecting outside of a circle. It says, then the measure of the angle formed is 1/2 the difference of the intercepted arcs. So if we're looking for this angle, we're going to take our two arcs and subtract them. So our formula, if you want to write out instead of having a very specific one, you're going to be looking for your angle, and you're going to say one of the arcs minus the other arc divided by 2. So let's look at the first example. Where's your angle? Well, it's the 58. So 58 degrees equals, the bigger arc is the 200, and the smaller arc is this arc US. So some of you may say, well, how do I know that? I mean, obviously right now it kind of looks like the 200 is bigger, but how do I know that on any other problem? Whichever arc is further away from your angle is going to be the one that's the bigger one. The reason it matters, we are subtracting. So when I say 200 minus the measure of arc US, it makes a difference if I say 200 minus the arc or the arc minus 200. We need to make sure that the larger one is the first one. So now multiply by 2. So 58 times 2 is 116 equals 200 degrees minus the arc that we're looking for. So then I'm going to add the arc that we are looking for, US, to both sides to make it the arc plus 116 equals 200. And then I can subtract the 116 to get that the measure of the arc is 84 degrees. Looking at this next problem, start with your angle. So see if you can pause the video and try this one. So the measure of angle C is, we have two arcs, 193 and 99. So 193 minus 99 divided by 2. So I have 94 degrees divided by 2, which means the measure of angle C is 47 degrees. So that's if you have a secant and a tangent. And some of you may notice, you may have already noticed, it's the same idea as what we just did with two secants. And that's always the case. The secant and the tangent, they're treated the same way. Why did I break them up? They look different. It's the same idea. It's just the picture looks a little bit different. But you treat them the same idea. Same idea for both of those. So now let's look here. If two tangent lines intersect outside of a circle, the measure of the angle formed is half the difference of the intercepted arcs. So looking here, half the difference of the intercepted arcs. That's the measure of the angle that you have that's formed. And that is identical to what we just did. So all three of these are actually the same idea. It's just the figure looks a little bit different. But anytime you have the angle formed outside of the circle, you subtract your arcs and divide by 2. So let's look here. This angle, you're going to take this arc, and then you're going to subtract this arc. Divide them by 2, and that'll give you the angle. Now, if you notice, this arc plus this arc makes the whole circle. And that's going to be something that comes in handy when you're dealing with two tangents. They are going to both add up to equal 360. So sometimes they'll give you one of your arcs. And if they give you one of the arcs, then you know, I'm going to fill in a number here. I'm going to say that this is, let's say, 210. So if I know that part of the circle is 210, I can find this part because it has to be 360 minus 210. So it has to be 150. So you can use that information for your tangent lines. That's not the case for the secants or for the secant and tangent. That's only going to be with the tangent lines. So that's something special. So let's look here. We're going to use that information on these examples, and it's a little bit different, and I purposely pulled some slightly harder examples on these to make sure that we understand what our options are. So just like the other ones, we're going to start by identifying our angle. So our angle is the 74 degrees. Then we have two arcs. One of them is this bigger arc. I'm going to call it B because it's the bigger one. You pick a variable. Then we have this one, and I'm going to call it L for the little arc. Doesn't matter to me which one you pick, but B and L. So we take our two and we subtract them. So B minus L, and then divide by 2. Just like we've been doing, the angle equals the arcs, the difference of them, divided by 2. So then I can get rid of the fraction by multiplying by 2, and I end up with 148. And so that's B minus L. I can't solve that formula. However, I know arc B and arc L together equal 360. B plus L equals 360 because they form the whole circle. So I'm going to write it like this. B plus L equals 360. And if I set it up like this, it is perfectly set up for elimination, where you add your equations together. If you don't like elimination, you're welcome to do substitution. That's up to you. This is just one instance where it's set up to do elimination quite well. So add your numbers together. 148 plus 360 is 508. B plus B is not B squared, it's 2B. Negative L plus L cancels. It eliminates. And so then divide by 2, you should get that B is 254. And that's what we were looking for, this arc right here. If you were looking for L, you could use either one of these equations. The one I'm going to pick is that they have to add up to equal 360. So if I was looking for L, you would do 360 minus 254. So 106. But they didn't ask you specifically for L. But that's how you could find it if you wanted to. So now let's look at the next example. Again, we have the angle. So 76 equals. So I'm going to name my arcs again L and B for little and big. And so I can say the big one minus the little one divided by 2. So multiply by 2. And so I have 152 equals B minus L. And again, I'm going to use the same fact that the two arcs add up to be 360. And again, if you do elimination, you end up with 512 equals 2B. And the L's eliminate, meaning your B is 256 degrees. So if you were looking for both of them, you would just take 360 and then subtract the 256, and you would be left with 104 for your little arc. So hopefully that helps you with understanding how some of the angles in your circles are related. I know that's a lot of different options there, but these are really important that you understand the difference. So that's why it's important for you to practice with each of these concepts.